Welcome back, everybody. Today we're going to look at flow, and this is part of the Pipe Dreams Ramda Deep Dive Season 2, the follow-up to a previous series that was unfinished on Ramda. Pardon me. So we're going to look at flow, and I have no idea what this does. So let's dig in, see if we can figure it out. All right, so it takes the value of an expression and applies it to a function which is the left to right serial composition of the functions given in the second argument. So I just read that. I have no idea what that means. So, especially the left to right serial composition. So, takes the value of an expression, right, and applies it to a function, which is the left to right serial composition of the functions given in the second argument. The functions in the pipeline should be unary. Okay. So, one argument. So let's look at the type signature and here. So it starts with just a value, the seed value. And then it looks like we have an array of functions, A to B, blah to blah, blah to blah, Y to Z, and then it returns a Z. So we're using some sort of pipeline. So, and it also says C also pipe. So there's some similarities. So this might be actually one of these really cool ones. The pipeline, the functions composing the pipeline. Okay. So again, feels a lot like a pipe. And it returns asterisk Z or Z. Not exactly sure what the asterisk is, but maybe it means Z can be any type. The result of applying the seed value to the function pipeline. Okay, so I still have no idea what this does. I'm sure that the example here will tell me, but let me keep reading. The flow helps us to avoid introducing an extra function with named arguments for computing the result of the function pipeline, which depends on a given initial value or on given initial values. I still am clueless of what this means. Rather than defining a referential transparent function like f takes an x and a y, and then pipes. Okay, so I see. So we're dealing with multiple arguments. So like you apply g to x, h to y, and then I'm guessing like I to z, which is only later needed once. Hmm. Okay, in some libraries this function is named pipe, so that's interesting. So it's got to be very similar to pipe. So we're programmers. We don't read words. We read code. Let's look at the code example here. So well, we pass it 9. That's our seed value. And then we have an array of functions. So instead of like pipe doesn't, you don't need to pass an array of functions. You just pass the functions. And this gives us -2. So how would that work? So are we applying, okay, so if we said 9, we take the square root of 9, that's 3. Then we get -3. Then we increment it, we get -2. So that's interesting. I'm still not sure. So it feels a lot like pipe, but I'm still not sure exactly what the difference is. Let's see if we did. Let's go look at pipe real quick. So with pipe, we're just passing in the functions and stitches it together like one function. And we run the value. Here we pass, yeah, two values. So 3 to the power of 4 is what? I don't know, big number, 981 something. We negate it. Okay, so we're passing two values here. We get one value back, we negate it, get one value back, and we increment it. Here, okay, so the main difference is we're passing the value as the second argument, not just the function. So it takes the value of an expression and applies it to a function. But where's the expression? I mean, is 9 the expression? That's what's confusing. It applies it to a function which is left to right composition, so like piping. I think I'm just going to ignore the word serial. Yeah, serial versus parallel. So parallel would do like all these things at one time, but this is serial composition, so one at a time. The function's given in the second R. Okay, so flow. Well, that's weird. Flow is helps to avoid. I think that's a typo. Flow helps to avoid introducing an extra function with named arguments. Rather than defining a function that takes an x and y, which is only later needed once. Yeah, I guess it's just more of a concise way of using pipe. Hmm. Let's look at more of the examples. So we got this person object with first and last name, Jane Doe, and then we're creating a full name. We pass in the person object. Yeah, I think I understand this. Even though it says takes the value of an expression, like I would not consider person object to be an expression or the number 9 to be an expression. I would consider those to be values. But I guess you could say like 3 plus or 4 plus 5, and that would be an expression. And then we would pass that result through the pipe. Here we've got an object, and so we get the values, which would be Jane and Doe, probably is an array. Yeah, because then we join it with the space and we get Jane Doe. Yeah, so complicated description, but it looks pretty straightforward. Let's look at this one. Give a name. We pass it this string of empty characters, like a kind of like a tab or something. Then we trim it so we get an empty string. And then we're using this when function, which we haven't even looked at yet, but it's got to be like an if statement. So when is empty, which would be true. We get back the full name, which is the result of this function. That's interesting. Let's try to think of something to use. So we'll log something. Yeah. So if we did art up flow, wondered, yeah, this is the same description here, quite long, but yeah, art up flow. And so, pass it 32, and then we could pass it the functions we want as the second argument. So let's use random functions. Let's do like r.add two, r.multiply three, r.divide. Let's use flip, r.flip, which we looked at last time. And let's do multiple lines here. This is the first argument, 32. There's the second one. And let's do r dot divide. So 4 for no reason. Right. So we take the number 32 and then we add 2 to it, multiply by 3, and then divide by 4 is what this would be. Instead of 4 divided by the result of this one, because we're flipping the arguments, which is flip is really handy when it comes to subtract or divide, um, because you might already know the second argument and we want to divide by 4 or whatever the first argument is. So let's give that a shot. Save it, run it. What do I do? Node dex.js. I get not a number. Interesting. I'm doing something wrong. Let me get rid of the flip. Simplify it. Okay, so there's something about that flip. What was it about the flip? Ah, I do this all the time. You flip the function and then provide the argument. Yeah, that's right. 25.5. So I'm not going to do the math, but I'm assuming that's it. And my prettier is being too helpful right now. Um, break it up so I can see it a little more clearly. There's the first argument, second argument. I'll even break it up like this. Yeah, let's see. Can we tap into the pipe and do console.log? Or I could just say log. So alias it above right here. Yeah, where's my tap? There it is. All right, so we can just step through it. So start out at, why am I getting two console logs? Oh, because we're logging this. Let's not log it. Yeah, okay, so we passed in 32, hasn't done anything. With pipe, add two, that looks right. 102 when we multiply it by 3, and then if we divide by 4, it's 25.5. Missing the comma? Yeah, 25.5. So yeah, and now it says takes the value of an expression. So we could say like 16 times 2. That work? Is that an expression? Yeah, that works too. So I mean, I guess you could say like, oh, oh, not, sorry, I was working with another library that started with a capital C. R dot multiply. We could just say 16. And, oh, we could do it all together. In 2, get the same result, and we do. Yeah. So I wish their documentation was a little bit more similar to their examples. But the difference is like, how does this differ from pipe? Let's try to recreate this second or this same thing with the pipe. So, oh, I see. This is actually really cool because it annoys me to do the same thing with a pipe. I often do this. Like I know what the starting answer is. I don't need to call the function and pass in the data. Like the data is already known for this particular pipe. So I could say, take these same functions and put it in the pipe, stop it prettier. I just want it to look kind of similar. All right. So I do that, and if I log this, let's comment this out. Yeah, so we get a function, and the function, uh, well, it's going to get the length, but I can't really do that because it's not assigned anything. But anyway, if I wanted to get the same result, I would need to invoke this pipe function with this 16. Well, let's do the r dot multiply 16 and 2. I get 25.5. So the thing is, like, we've got this nice little pipe. Let's say we name this calculation, just a random thing, and we assign this pipe function to here. And this is when I really start thinking things like Legos. Like if each function was a Lego, you know, we stick the Legos together, and now we've created this calculation function. So, like, I think of pipe and compose as just basically grabbing ingredients off the shelf, if each ingredient was a function, putting them together in order, and creating this new ingredient, this like super ingredient. And I could call this, so like I could call calculation with, can I do this? Can't remember. Yeah. So it's saying it takes the value of an expression and applies it to the function. Now, honestly, I thought the correct terminology was you apply the function to the value, or apply the function to an expression. And I've heard it both ways, so now I'm confused. It's kind of like function arguments versus parameters. Like everybody uses those interchangeably. You don't know what's what. But here it says applies the expression to a function, which is left to right, just like a pipe. Yeah, the functions given in the second argument, which is an array of functions. The functions should be unary. Functions in the pipeline should be unary. So I don't think, yeah, this is unary. So if I didn't add two here, yeah, that wouldn't work anyway. I mean, if we're adding, we have to add two things. So yeah, these are all unary functions. And the first one is the result of an expression. So flow helps us to avoid introducing an extra function with named arguments for computing the result of a function pipeline, which depends on a given initial value. So I think what this is saying is rather than finding a function which is only used once, it can be avoided. So like, are they saying that like um, multiply by two equals r dot multiply, and we partially apply it with the first argument of two? Um, and it's saying it helps us avoid something like this, where we have this function that just calculates the initial value that goes into the pipe. Like we can do that in the pipe. Yeah, rather than do all that, Let me grab this and put it at the bottom and comment that out. So we only have one log. Yeah, we're just doing it like all at once. So actually, to make this a little bit more like the last example, let's uh let's call this const calculation equals all this business. Get rid of this. Let me just delete this. Now everything's, yeah, format it. Um, so here, I mean, we could just log the calculation, right? That should give us the same thing. That's actually really handy because otherwise, you have to pass the the initial expression here, which we're using a function for the expression. You would have to pass this down here, if you're using pipe like that. Oh, I got to copy the wrong thing. Yeah, if this is pipe, get rid of that. Get rid of because pipe doesn't need an array. Yeah, that should be the same thing, and it is. And it's just weird. You're putting, I mean, it's not any weirder than a lot of other functions with Ramda where you're invoking things with like multiple sets of parentheses, one at a time. If you already know that this calculation is going to be 32, or what the two numbers are, or whatever complicated expression you have, you can go ahead and just and put it in there. The other thing you could do here is you could take this and put it here, and I think that's what they mean by something about a referential, yeah, rather than defining a referential transparent function, so you can call this here like that, like calling it like a function, or you can invoke it here and just call calculation, which is just a value. It's not a function at this point. Yeah, you get 25.5. Yeah, this is actually really, really handy. There's a lot of times that I create kind of an intermediate value or something using a pipe, but I have to call it like this. And it just feels cleaner to put everything inside. I'm going to go back to flow. It's not working. Nope. What did I do? Product flow multiplies the first. Oh, I left this here. Yeah, clean it up. We still get 25.5. So yeah, I mean, honestly, I use pipe so much. And like I said, for me, functional programming is all about building up functions from uh, very what's the word I'm looking for? A function that really only does one thing, one small, simple thing. And I want to take those things and put them together with a pipe to build my own more complex function that's probably more specific to the thing that I'm trying to achieve. In this example, this arbitrary calculation. Um, like add two, multiply three, divide by four, those are not specific to any business domain problem, business logic. But when I put them together, I create this calculation, that might be specific to something someone needs. I feel like I'm going to reach for flow a lot more. Um, yeah, yeah, I was just trying to think. I don't know if I need to go too much farther. And, we've already looked at pipe. So we're moving right along. But yeah, this is really cool. And I'm proud of myself because, again, I've never looked at this function. So I'm starting from scratch, had no idea what I'm doing. And even though the description kind of threw me off, the type signature actually helped me quite a bit. So I'm getting really used to reading this type of type signature. I like this a lot better than TypeScript. TypeScript just looks so ugly to me, and I find that I spend more time trying to get rid of the red squiggly lines in TypeScript than I am trying to solve the problem. Uh, Not to say you shouldn't use TypeScript, or you should, you know, figure that out on your own. And it looks like this was added pretty late in the game, version 30. We're in version 31.3 now. But anyway, somebody's coming home and they're going to make noise. So I feel like this is a good time to stop. And next we'll pick up on for each, which I think we all know what does, but I'm interested in how it handles the functional aspect. So anyway, thanks for spending your time with me. Tell a friend, and I'll see you in the next video.